something that's in Pell Equation form where it's actually easier since this is a perfect square. 49 is a perfect square. But just to be clear, I'm just looking for the positive solution. So 0, 3, let me make up something else too. Say minus 2, 5. These type of ordered pairs would not be a member of n cross n, right? So we're just looking for positive integer ordered pair solutions. Alrighty. Now, so an approach here is, there's more than one approach obviously on any problem, but you go ahead and exploit the difference of two squares formula. I'm not worried about the 464 just yet. I just want to see if we can find out some general relationships between the pairs here. So you get this, and I call it AB. It's kind of easier just to talk about it as a single letter. Okay, so we let A equal to x plus 7y and B equals to x minus 7y. That would mean that A is, of course, the bigger number. Now, it's very clear that A minus B is a multiple of 14 because you can just see this would be equal to 14y, right? This would be equal to 14y. If you just subtract B from A, the x's cancel and you're just left with 14y. So that's where this multiple of 14, that ends up excluding a lot of things. And in a similar fashion, if you add these things, the 7y's cancel and you just get 2x. So A plus B would actually just be an even number. So if you run into a circumstance where A plus B is not even, or A minus B is a multiple of 14, not a multiple of 14, you can just discard those potential solutions. Now we'll look at the constant term here, y'all, 464. Now, the relationship right here, and this is a very fundamental number theory combinatorics result, the number of divisors, and I'll just write div number divisors. You take the product of each of the exponents, incremented. Okay, and that's, you need to allow for 0 to be an exponent. Since one can be one can be a factor, you have to allow for 0, 1, 2, 3, 4 right here, and for 0 and 1 right here. So that's why you have 10 divisors. So what I've done, and it's nice to kind of know that, it's not necessary to do that, but at least you know when you finished up all the divisors. And so I've gone through here and listed these divisors. We have 2 divisors, 4 divisors, 6 divisors, 8 divisors, 10 divisors, right? And they pair up. Now notice right here that this would fail the 2 right here. It has to be an even number, but when you add this up, this sums to an odd number. 464 plus 1 is odd, right? And we know from the more general work we did up here that when you sum the two zeros or the two factors, that has to be even, right? And same thing right here, 29 plus 16 is odd, right? Is also odd, right? So that, what does that mean? That means just under general reasoning, we can exclude those two pairs of this pair of divisors and this pair of divisors right here. Now, so it's down to these two. Now, these all three of these meet the condition, but notice right here, if you do 116 minus 4, that's equal to 112, right? And that's equal to, is that 14 times 8? That's equal to 8 times 14, right? So you see that 8 times 14 is 80 plus 32, which is 112. So you see it meets that condition when you subtract them. You get a multiple of 14, all right? Now, the rest of these you can verify that that doesn't happen. 232 minus 2 is not a multiple of 14. I'll just put not 14K. Again, if you could check that if you want to, and make sure I didn't make a mistake. And then right here, 58 minus 8 is not a multiple of 14, right? So that just leaves 1/16 and 4 to consider. So we would actually look at right up here. Let's just go right up here, folks. Call this is the biggest one, 1/16. Okay, and then this is the smallest one, 4. Okay, so it doesn't take much. It's fairly quick. Well, actually, you can just look at it, right? 2 times, let's see here, we have 1/16 minus 4, so that would give you 1/16 plus 4 is 120, right? So let me just write it right here. This is a little sloppy, but we'll live. Okay, 1/16 plus 4, which is the one we see has the difference of 112, is equal to 120. And that tells you that x is equal to 60, right? Okay, so you can see pretty quickly that x is equal to 60. And just by substituting, you see that y is equal to 8. And you can check it on either side, folks. If you have 60 right here and 56 right here, which is 7 times 8, you get 1/16. And the same thing right here. If you have 60 right here, 7 times 8 is 56. 60 minus 56 is 4, right? So this is our ordered pair solution right here, folks. 60 and 8, and it's the only one. Now, I believe there are some negative solutions to this equation. I just want to keep it short and sweet, so I just left those out. But I believe there are some negative solutions also. So the only solution that I found would be the ordered pair 60, 8. Okay, and that, I believe, that's it, folks. I don't have anything else to add here. And I really think this work up front is very useful, especially in the event that you had a lot more divisors. We only had 10 divisors to consider. But if you have a larger list of divisors, making these general observations about what the divisors have to, the type of properties the divisors have to have, is very useful, actually. You see, this a minus b has to be a multiple of 14. There was only one pair of divisors where that occurred, and that was turned out to be our answer, our only answer. 1/16 times 4. 1/16 minus 4, of course, is 112, which is a multiple of 14. None of the others enjoy that property. And you could get rid of 2 of them real quick just on this odd condition. Okay, so again, not a particularly long list here, and you could have just done it by going through all the possibilities without going through this prelim work. But this makes it more of a formal mathematical, like when you're done sort of thing, to go to the trouble to do these steps right here, in my opinion. All right, that's all. Good night.